Welcome to this video in the nomenclature unit. This is 5.2, where today we are going to continue our journey into Unit 5. Video 5.2 will cover naming and formula writing of binary ionic compounds containing metals that form one type of ion, binary ionic compounds containing your transition metals that may form more than one type of ion, and we will introduce to you ternary ionic compounds containing a mix of monatomic ions from the periodic table and polyatomic ions on table E. If you haven't already done so, please make sure you've got your chemistry notebook handy, you've downloaded and printed your companion worksheet, you have a writing utensil and a periodic table and C-cert at the ready. We got lots of work to do today, so let's get going. Today's video is going to kick off teaching you how to name binary ionic compounds. And we are going to have to use the rules that we learned in our last lesson to help us do that. So if you have to look back in your notes, please do. You are also going to need your periodic table for this, so make sure you grab that and have that handy. Part 1, binary ionic compounds. Binary ionic compounds are indeed ionic compounds containing atoms of two different elements in it, and they are always one or more metal ions followed by one or more non-metal ions. So when we want to recognize that we have a binary ionic compound, you gotta look deeply at the formula. And here you'll see we have NaCl. The fact that NaCl is a metal and Cl is a non-metal tells me that I have a binary ionic compound. So our formula is always going to be metal and non-metal, with the first atom being the metal in the binary ionic compound. That is very important for you to recognize because that eventually is going to dictate how we name the compound. Which brings us to naming of binary ionic compounds. The naming rule is pretty simple. What we do is we take the name of the cation and we follow that by the name of the anion, and then we drop the word ion from both names. So let's look at these examples here. Here I have NaCl. I recognize it's a binary ionic compound because sodium is a metal, so I'm going to name the metal ion first. From last video, I know that that's a sodium ion. And I'm going to name then my non-metal, and I know that's a chloride ion. Remember that we add the suffix "ide" and the word ion to that. And then, as it says here, we are going to drop the word ions from both names, leaving us with sodium chloride. Super easy. Let's check out this example over here. Is this binary ionic? Well, I got to go to my periodic table and I see magnesium is indeed a metal, so this is a binary ionic compound, so I'm going to call it magnesium ion. And that magnesium ion is followed by two bromines, which are nonmetals, so that's going to give us bromide ion. And of course, we're dropping the word ion from the name, and that gives us magnesium bromide. Now, you may be sitting there wondering, because there were two bromide ions, did that fit into the name somehow? And the answer is absolutely not. The number of ions in the formula of the binary ionic compound does not change the name. And you're going to see why when we get into the formula writing aspect of it later on. So put that on hold just for a second. So now it is your turn. Let's see if we can name these binary ionic compounds. Pause the video now, and when you're finished, unpause for the answers. All right, if you did this correctly, here is what you should have gotten. One of the things you were going to see is that number 8 was not named copper chloride, probably like you had it. You'll notice I put in Roman numerals here. Well, in the next part of this video, you're going to find out why copper chloride needed a Roman numeral of a 2, and yet examples 1 through 7 did not. So let's go check that out right now. This next section is going to help you guys figure out when to use a Roman numeral in a name when looking at a formula that contains a transition metal with 1 or 2 oxidation numbers. So here we go. The rule is pretty simple. If the cation can have more than one potential charge, then the charge must be specified with the metal's name using a Roman numeral. Our example that we saw before was here, and we know that the name of this is copper 2 chloride. So how did we figure out that the copper plus 2 ion was the correct copper ion to use in the formula for copper 2 chloride? Well, that is what we are going to dive into, because we can see here that copper can indeed have two possible oxidation states. So the rule is essentially that your compound, no matter which charge for the copper that you use, has to create a compound that is electrically neutral, having the same number of positive charges as negative. So we have to maintain what is called electroneutrality. So the way we do it is pretty simple. What I suggest is when you have a formula like CuCl2 and we don't know which charge of copper is used, you list both on top. So +1 and +2. And then these are the only possible charges you have. Now we know that our anion is going to use the first charge that's there. And so that's going to give us 2 chloride ions at -1. That gives us a total of -2. We know the whole thing here should be neutral. So whatever this copper is, it would be like saying x plus -2 equals a 0. Well, if we thought it was +1 and we put a +1 in there, +1 plus a -2, would that get a 0? Heck no, that would give us a -1. But if we put the +2 in there, +2 plus a -2 does indeed get us 0. So now that we know that the +2 charge of copper is our choice to make our compound neutral, we can now say and write the name of this compound, which we know because it's the +2 charge, it is copper 2 chloride. So that is the way to dissect formulas when you don't really know what charge they're using. Do a little bit of algebra, list all the charges, figure out what cancels it out to make it 0, and that will set you on your way to using the correct Roman numeral in your name. So now it's your turn. Here are 6 examples of ionic compounds that contain transition metals, which may or may not need Roman numerals. So make sure you consult the periodic table before you name, list all your charges, and then figure out what you have to use to cancel out the negatives and leave you with an electrically neutral compound. Pause the video now and then unpause when you're ready for an answer. All right, if you did this correctly, you will see that all of these required the use of a Roman numeral in the name, which means that every single one of these is polyvalent, meaning it could have more than one potential possible charge. So if you did make any mistakes here, make sure you go back and rewatch the section on figuring out which Roman numeral you need. Make sure that you used the charge for the cation. That would indeed cancel out the negative charges, leaving you with a neutral compound. Okay, part 3 of this video is going to have us learn how to write formulas of ionic compounds from their names. We're going to use a little bit of the last section that we just learned about in order to do this. So the question here on this slide asks, what is the formula for calcium chloride? So how would we go about writing that formula? Well, let me remind you guys of something. Recall that when you have an ionic compounds must be neutral and balanced for charge with a net charge of 0, which means you have to have an equal number of positive charges as you do negative between the 2 ions that make up the compound. So if you have written it correctly, all the opposing charges should be canceling one another. So we call this balancing for charge. And we do this by adding subscripts to our symbols. Sometimes you don't need to add a subscript, but you guys will see that. So let's go dive into how we write the formula for calcium chloride. So how do we do this? Well, the first thing we have to do is realize that ionic compounds all contain metals and non-metals. So I'm going to look for my metal ion first. I see it's calcium. I look in the box and I see that calcium typically has a charge of a +2. I go look at the non-metal and I see it typically will have a charge of -1. Remember, we are only using the first charge for our non-metals. So that gives me Ca +2, Cl -1. Is it neutral in a 1-to-1 ratio just like this? And you guys should be at the point where you realize that we would be more positive than we would be negative if we left it just as CaCl. So now I got to add a subscript to one of these. And the way we're going to do that is by looking at this, I know I got to make a net charge of 0. So I can't take away charge because this is overwhelmingly positive right now. So I'm going to leave that like that. But I can add a subscript to this side over here in order to balance the charge. I have one chloride that's here at -1. I have one calcium that's here at +2. If I add a second chloride here, that gets me 2 times -1. That gets me -2. And if I say +2 plus a -2 gets me a 0, that would indeed be neutralizing the charges. So my formula for calcium chloride would indeed be CaCl2. And of course, I want you guys to write your charges in to make sure you can do your bookkeeping. So now it is indeed your turn. Try writing formulas of these ionic compounds and see if you can create electrically neutral compounds by making sure you have the same number of positive charges as you do negative. Pause the video now and then unpause when you've got an answer. All right, if you did this one correctly, here is what you should have gotten. So 1 through 5 are binary ionic compounds, and you can see the way that I did the bookkeeping underneath all of these, where I was doing a little bit of algebra in order to figure out where I needed some subscripts to be placed in order to make my compound neutral. Number 6, however, is an example of something called a ternary compound. And you'll notice that my anion that was here was a hydroxide ion. It was not a monatomic ion from the periodic table. This guy came from table E and your polyatomic ions. So our next section is going to delve into how to name ternary compounds and eventually write their formulas. Check it out. You guys will notice this next section is called naming ternary compounds. And in order to do that, you are going to need table E. So grab that and let's get going. Ternary compounds are ionic compounds that will contain one or more polyatomic ions. So everything we have been doing in this video thus far has been using monatomic ions like nitride, sulfide, or chloride. But now we are going to be dealing with polyatomic ions that are just groups of atoms that carry a charge like this. A ternary compound is an ionic compound at its heart. So when you build them, the charges will have to cancel, but we'll get into that later. In the meantime, let's talk about naming. Let's say I get an example of something that we have to name that looks like this. And the first thing that should strike me is this is indeed not a binary ionic compound. Is it ionic? Well, the first thing I'm going to do is say, what do we have here? This is sodium. And so sodium is a metal. And when you have a metal as your first element that is in your formula, this thing is definitely ionic. But is it binary? And the fact that I have more than 2 types of atoms that are in there, well, that tells me this is not indeed binary. I have 1, 2, 3 different types. That tells me this is a ternary compound. So I have to name this a little bit differently because now I got a polyatomic ion in there. So to name it, 3-step process. Let's name our monatomic ion as I have previously learned in the video. So I know that this is a sodium ion. And now I want to include the name of the polyatomic ion that's in this particular formula. So I see NO3 here. Now I have memorized my polyatomic ions, but hopefully you have too. But if you didn't, go take a peek at table E, which is over here. And if I go down to the second column, I see NO3 minus is a nitrate ion. So I'm going to write nitrate. Then I am going to drop the word ion from both names. So let's get rid of that. And I am left with sodium nitrate. And that is the name of my ternary compound. Let's do another example. And this one is going to be a little bit more difficult, but I have faith that you guys are going to be able to get through it. Let's say you're asked to name FeCO3. So the first things you have to ask yourself is, number 1, is this ionic? And if so, what ions are in FeCO3? So the first thing I see is that is Fe. Fe is iron, and that is a transition metal. So it is a metal, and you know when you have a metal, that means you have an ionic compound. That's the first step. Now, what ions are present here? Well, I have iron and I have the CO3 thing. I see 3 different atoms that are here, so I automatically know that this is a ternary compound. So I got to figure out what CO3 is. First thing I'm going to do is that. I'm going to go to table E and I go down the column and I see, there's CO3. It's carbonate. So this is a carbonate ion. Now I'm going to do the heavy lifting. I have to name my monatomic ion that's here. So I kind of did this in reverse, but it's okay. You can do it either way. This is iron. And if you remember, iron's a transition metal, which we see here. And whoa, wait a second. We have more than one possible charge. So we have to figure out what charge got used for this compound. The way we're going to do that is a little bit of algebra. So let's peek at this. If I know the charge of carbonate, that's here, is equal to a -2 charge, so this whole carbonate there gives me -2, I see a 1-to-1 ratio of iron to carbonate, and I'm going to, like I strategized before, list both my charges of iron that are there. Which one of these irons is going to give us a neutral compound when combined with carbonate? One of these things, whichever it is, when you add it to -2, gets us electroneutrality and gets us neutral. Is it 3? Well, heck no. If it was 3, your compound here would be overwhelmingly positive, be +1. But if I use a +2 here, +2 plus -2 gets me 0, that gets me electroneutrality, and so I know the charge of my iron here is an iron to ion. So the whole name of this whole compound winds up being iron to carbonate. And that is how we do it. So now it is your turn. Let's take everything that we have just learned in this video and try and name these ternary compounds. Make sure you peek at the periodic table to make sure that your monatomic metal is not a transition metal and does not need Roman numerals. And then name your polyatomic ion as it would be on table E. So pause the video now and then unpause when you get an answer. Okay, if you did this correctly, here is what you should have gotten. Now, these can be a bit confusing, so make sure if you do have any burning questions, you bring them to the burning questions segment tomorrow, because this is an important step in being able to name and formula right. Part 5 of this video is going to be now writing formulas of ternary compounds. So I'm going to give you a name and you are going to write the formula. A couple things we have to remember is that our polyatomic ions are indeed ions, and they would carry a charge just like a monatomic ion would. So down here we can see some monatomic ions like nitride, sulfide, and chloride having -3, -2, and -1 respectively. And we have some polyatomic ions like nitrate, sulfate, and ammonium. They have charges of -1, -2, and +1. So it doesn't matter that there are multiple atoms that are here. This whole grouping carries the -1 charge, just like this ion would be -1. And that's going to be important in a sec. So when we build the formula of a ternary compound from its name, we have to remember that the charges are going to cancel out, which is important. And that's going to make them electrically neutral and give us a net charge of 0. So let's take an example here. Let's say I want to write the formula for calcium phosphate. Well, it is a two-step process. What I'm going to first do is list each ion with its charge. So that gives me a calcium ion. Got to go to the periodic table and look and see what the charge of calcium is. And I see, it is +2. So there's only one charge here. That's good. And a phosphate ion. Phosphate is not phosphide, it's phosphate. So that tells me it is off of table E and our polyatomic ions. So I'm going to go to there and look, and I see phosphate is indeed a PO4 3-. So I have to ask myself, in a 1-to-1 ratio, are these guys creating a neutral compound? So I have +2 and I have -3. That makes this overwhelmingly negative. So that is not the case. So if your compound is not neutral right off the bat, you've got to balance for charge and you've got to add subscripts. So the total charges cancel, giving a net charge of 0. So let's take care of the calcium first. And one of the things you can do is say, well, what is a common factor of both 2 and 3? Well, 6 is a common factor. So what would I have to multiply 2 by to make 6? And that answer is 3. So I'm going to do this in a different color ink here. So I'm going to give calcium a subscript of 3, and that gives me +6 as my total charge. I know I got to make whatever for my phosphate that gets me to 0. This whole phosphate is -3. So if I'm going to say, well, I have 3 and I'm trying to make 6, I got to multiply this by 2. I cannot put a 2 here, otherwise it looks like now I have PO42. And I got to tell you, PO42, I'm not even sure what that is. So I have to make sure that I use parentheses when I do this. I'm going to put the whole polyatomic ion in parentheses and then put a 2 here to give me 2 times -3, which is -6. And if I add 6 plus -6, that gets me 0. So my formula is Ca3PO4 parentheses 2. And I'm going to include my charges because I want to make sure my bookkeeping is right. So that is the formula of calcium phosphate. Now it's your turn. You guys try and write these formulas. Go through the same steps that we did. Remember, if you need to add a subscript to any polyatomic ion, no matter what it is, you must enclose it in parentheses so you don't have strange subscript errors. And at the end of the day, you are trying to make neutral compounds, so make sure your positive charges cancel out the negatives. Pause the video now and then unpause when you're ready for the answer. All right, if you did this correctly, here is what you should have gotten. Remember, you're building ionic compounds that need to be electrically neutral, so the charges that are positive and negative need to cancel. And if you needed to add a subscript to a polyatomic ion, make sure you enclose the polyatomic ion in parentheses. So that is it for me. Make sure you guys have nailed down the content that we have. And of course, if you have any burning questions, you bring them to the burning questions segment during our next session. It has been a pleasure taking you through part 2 of nomenclature. I'm looking forward to doing acids and bases and the traditional and the stock system with you next. But that's it for me for today. Peace out.
That's all, folks.